Hello, algebra students. Now that we have been working a little bit with quadratics and we've been working with parabolas, that's the shape of the graph when we graph a quadratic, we're going to talk more specifically about some of those parts that we're seeing in the parabola. So I've got kind of a lot going on here on the screen. The graph you can see is of a parabola. This equation is what we call standard form for a quadratic. When we looked at this in earlier lessons, a lot of times we had the entire thing reversed. So we would have the c first, and then the bx, and then the ax squared. When we're looking at this in standard form, when we're doing all this graphing, this is the way that we're going to be looking at our equations. We want them looking this way. It's easier to see the a, the b, and the c. And the a, b, and c are going to be really important. We're going to use those in this formula, and I'll do a couple of those with you in just a couple minutes. But that thing that I just put the star by, that is how we find the axis of symmetry. So if you're given a graph and it's already done for you, I don't need to do any of the math part of it, right? I can show you how to do that in just a minute. But on this graph, I already have the axis of symmetry graphed. The vertex is always going to be on that axis of symmetry. And this axis of symmetry in this picture is at x equals 1. Okay, that's a vertical line, never going to touch the y-axis. There's no y in the equation of the axis of symmetry. It's just an x because it crosses the x-axis and it crosses the x-axis, in this case at 1. We've already talked about what the x-intercepts are called. We're going to start calling them solutions. Earlier we were calling these zeros, need a different color. Looking at where it crosses the x-axis. So in this case, the zeros or the x-intercepts or the solutions of this particular graph are at -1, stay with green, and it also crosses, so right here is the -1, it also crosses at 3. The vertex is the turning point. It's either the bottom or the top of a graph, depending on which direction this is going. So that vertex will always be either a maximum or a minimum from the graph. In this case, it's a minimum. It's the lowest that this graph gets. That's the turning point. It keeps decreasing until it gets to the vertex and it turns around, comes back up again. So it's decreasing and then increasing. That's the turning point. That vertex, like I said, will always be on the axis of symmetry. We said this axis of symmetry was at 1, so, or x equals 1. That means that I already know half of my ordered pair. The x is 1. This vertex is at 4 down, so it'll be at 1, -4 is the ordered pair. I do have the y-intercept labeled on this graph, and we talk a lot about y-intercepts in linear equations. In this graph, it's not as important. We can look at it in terms of some shortcuts that we can find maybe from the graph eventually. But for right now, I'm just pointing that out because we already know what a y-intercept looks like, so we can see that in here as well. In this problem then, I've got this graph. The equation is on there, y equals x squared minus 2x minus 8. And I should be able to answer some of these questions. So I want to know the equation of the axis of symmetry. And again, because this is graphed, I can look at this and I can say, I know that this is my axis of symmetry. And that's at x equals 1. Let me show you just quickly where that comes from. Remember, this equation is really ax squared plus bx plus c. So in this, I don't see a number in front of the x squared. That means that the a is 1. I know that I should be adding the number in front of the x. I'm really subtracting, which means that the b is -2. And then the c is really going to be -8. If you remember from the last slide, the formula that we used for this, the opposite of b over 2a. And I'm going to say the opposite of b. Sometimes we just say -b, but I want you to make sure that you understand here if the b is -2, then the opposite of -2 is going to be +2. And this is going to be 2 times the a in this case was 1. So we'll have 2/2, which is 1. And that's what we had, right? If we have a graph, there's no reason to do that math, but I wanted to show you how that works. The vertex is at 1, -9. And in this case, again, this is a minimum. It's the lowest point in the graph. The roots, or the solutions, or the zeros, usually we're going to be calling these solutions now, are where it crosses the x-axis. It crosses the x-axis right here at -2 and at +4. When we do some other work with quadratics, when we're solving quadratics in different ways, we'll be able to bring it back to this and show you where that fits in with all of this. The turning point, the questions 4 and 5 are kind of repetitious from the earlier ones. The turning point is the vertex. That is at 1, -9. And then how many solutions does it have? 2, because it crosses the x-axis in 2 places. That doesn't always happen. So sometimes we don't get any solutions. Sometimes we only get 1 solution. But we have 2 solutions. And again, they are 2 and 4. I'm sorry, -2. Oh, I didn't write it. -2 and 4. Here's another problem. This time, my parabola is opening down. And we will be looking at what we can see in an equation to know that before we even see the graph. But the equation for the axis of symmetry in this one, right, here's my axis of symmetry without doing the math this time, since I have the graph anyway. The axis of symmetry is at x equals -2. The vertex is at -2, +9. Right, that's this point right here at the very top of the graph, and because it's the very top of the graph, that is the maximum. The roots, or the solutions, or again the zeros, and it looks like it's off by just a little bit, but it's really at -5 and +1. The turning point is that vertex. That's -2, 9. And how many solutions? We again have 2 solutions. They're -5 and 1. The times when we wouldn't have any solutions at all, if I would have a graph that would look, for instance, like this, that will never touch the x-axis. I would have 0 solutions. No solutions, I should say, because it's never going to cross the x-axis. If I would have a graph that would have the vertex right on the axis, I could have just 1 solution as well. Typically, though, we have 2. All right, so we can find the vertex. So far, I showed you how to find the vertex, or find the axis of symmetry anyway, with a graph, but I can do this without a graph. The vertex is always going to be on the axis of symmetry, so that's where we're going to start. We're going to find the axis of symmetry, and again, that equation is x equals, remember this is a vertical line, x equals the opposite of b over 2a. So when we have an equation, we are going to find the a, b, and the c so we can figure out what that axis of symmetry is. Once we know that x part, we'll have half of the answer, right? For a vertex, we need an ordered pair. We'll have the x, we just have to find the y. So to do that, we are just going to substitute that x value that we find from our equation, and we're going to put it into the regular equation that we have and figure out what the y is going to be equal to. So for this, the first thing that I want you to do, let me write this one more time. Y equals ax squared plus bx plus c. I want to know the a, the b, and the c. I know that the c is not part of my equation. That's okay, but we can still label things. The a is the number in front of the x squared, that's a 2. The b is the number that's in front of the regular x. It's not just 16, it's a -16. And the c is going to be 33. So to find the axis of symmetry, I would have x equals the opposite of b over 2a. The opposite of negative 16 is just going to be positive 16. Right, if you want to sneak a 1 in front of that, b, so it's negative 1 times b, and show that multiplication, go right ahead. I'm okay just changing that sign. And we're going to have 2 times the a is 2. So this is going to be 16 over 4. That means the axis of symmetry is at 4. I know that half of my answer is 4. I just have to figure out what the y part is. So this is, and keep in mind, I am writing out every single thing I can on this problem. You're going to be able to do a lot of this without having to write all this down every single time. But if the x is equal to 4, then I would have for my equation, y equals 2 times 4 squared minus 16 times 4 plus 33. Order of operations always matters. So I'm going to do my 4 squared right here. That's 16 times 2 is 32. 16 times 4, I already have my subtraction there. That's 64. So I'm going to have so I was just double checking my numbers there. 4 squared is 16 times 2 is 32. So 32 minus 64, just doing this part, I would get negative 32 plus 33 is going to be equal to 1. So without having to see a graph, I can find my vertex. Okay. Now, this one, I think we should be able to do a little bit faster. Again, I have my A, B, and C listed over here for like where to find them. So let's find my A, B, and C in this problem. The A, I don't see a number in front of the x squared, but you know that there's a 1 right there. So that's really a negative 1. B is negative 8, and C is negative 19. The axis of symmetry is the opposite of B. So the opposite of negative 8 would be positive 8. 2 times a negative 1. 8 over negative 2 is going to give me, this time that the x is negative 4. When I substitute that in, I want to be careful here. I'm going to erase that negative 1 that I put in there, because that negative that's in front of the x squared is not the same as the negative in front of the 4. Those are 2 different things. So I'm going to have that y equals negative or negative 1 times a negative 4 squared minus 8 times negative 4 minus 19. I'm going to strongly suggest use parentheses when you're doing that substitution. Now, this negative 4 squared is positive 16. But 16 times that negative 1 is going to be a negative 16. Negative 8 times negative 4 is 32. And if I would add those two together, negative 16 plus 32 is going to be positive 16. Minus 19 or plus a negative 19 would be negative 3. This you can absolutely do on your calculator to work through these problems for sure. The ordered pair for this will be at negative 4 for the x and negative 3 for the y. So today you've got a worksheet. There is an answer key in Schoology. You can absolutely check that. There's going to be a formative. I'm going to do one problem from each side of the worksheet with you. So number 1 on the worksheet looks like this. This time it says zeros. Remember I said we can call it zeros, we can call it solutions. After today, we're going to just be calling it solutions. So the zeros of this are at negative 4 and 0, because that's where it crosses the x-axis. The axis of symmetry, without having, they don't even give you an equation on this anyway. I purposely did that, so you would just have to look at the graph. Oh, my line's a little off there. My axis of symmetry is at x equals negative 2. This graph is opening down. So this point right here is at the very, very top of the graph, which means that it's a maximum. And the vertex, that ordered pair, is going to be at negative 2 for the x and 4 for the y. So that's what you're doing on the front side of the worksheet. On the back side, I have problems like this, and I want you to find the vertex, okay? So let's start with A equals 1, B equals 4, C equals -7. I'm going to have X equals the opposite of B over 2A. The opposite of 4 is going to be a -4. 2 times 1. So I'll have -4 over 2 is -2. That's what the X part is. If you wanted to start your order pair right now, you could. You've got half of it done. The Y, I'm going to have Y equals -2 squared plus 4 times the -2 minus 7. -2 squared is +4. 4 times the -2 is a -8. 4 minus 8 is -4. Minus 7 is going to be -11. Okay, so that's an example from each side of your worksheet. Feel free to go back and rewatch if you need to, or reach out to your teacher if you need some help.